Okay, we're going to continue adding and subtracting rational expressions. In this case, we're going to have some cases where there is a common factor that exists in the denominator, but not all of them will be common. So, when we take a look at the first example, it's similar to an example that we had previously done. I can see that I have an x in both the denominators, but if I look at the coefficients, I have 5 and 10, which means that the common denominator, or LCD, is going to be 10x. How am I going to get that? Well, I'm going to multiply the first fraction by 2 in the numerator and denominator. So when I multiply this by 2, I'm going to get 6 minus 3 all over 10x, which is just going to give me 3 over 10x. And don't forget the restriction, x cannot equal 0. When I get to example B, I can see that I have binomial denominators, and they can actually both be factored down. So that's where I'm going to start. I'm going to say that this is going to be equivalent to 4 over 5 bracket x plus 1 plus 3 over 2 bracket x plus 1. And we can see, just like in the previous example, we have a common factor. In this case, it's the x plus 1. So then I just have to look at my coefficients, and between 5 and 2, it's going to be 10. So I need to multiply the first set by 2 on the top and the bottom, and the second set by 5 on the top and the bottom. That's going to give it all over the common denominator of 10 bracket x plus 1s. And if I have 2 times 4, I have 8, and 5 times 3 is going to give me 15. This is all going to be the same as 23 over 10 x plus 1. I can't factor anything else out of the numerator and denominator, and I just need to state the restriction that x cannot equal -1. When I get to example C, then I'm going to factor down the denominator of the second term. The first one I can't factor down at all, so I have 1 over x squared minus 1 over x and x plus 2. Now in this case, there is a common factor of a singular x in both cases, but we can see that this one actually has 2 x's, and this one has an x plus 2 that's not the same, which means that in order to make them match, I have to multiply this one by another x, and this one by x plus 2. So I have x plus 2 minus 1 times x all over x squared times x plus 2. This is the same as x plus 2 minus x all over x squared times x plus 2, which I can simplify just to 2 over x squared times x plus 2. And this is true so long as x does not equal either -2 or 0. The -2 comes from the binomial, and the 0 comes from any time I have an x outside the brackets. When I get to example 2, I'm going to look and say, well, is there anything that's the same? And there is. They both have an x minus 2. So what is different? Well, this one has an x plus 1 that's going to be needed on the other side. And this one has an x plus 4, which is going to be needed on this side. So when I look at all the different factors, that's my lowest common denominator. So I'm going to take this and I'm going to say that it's going to be equivalent to 5x plus 4 plus 2 x plus 1 over all of the different factors, x plus 4, x plus 1, and x minus 2. This is going to be the same as 5x plus 20 plus 2x plus 2 all over x plus 4, x plus 1, x minus 2. And when I combine the like terms, this is going to give me 7x plus 22 over x plus 4, x plus 1, x minus 2. And this is true so long as x cannot equal -4, -1, or +2. For example 3, now we need to factor down to see what the common factors are. So I need to factor down the left, on the right. It's already at its lowest common factor. So I'm going to say that it's going to be 4 over, when I factor p squared minus 1, p plus 1, p minus 1, plus 2 over p plus 1. And we can see that the p plus 1 is the same in both cases, but the second one is missing the p minus 1. So I'm going to multiply it into the top and into the bottom. This is going to give me 4 plus 2 p minus 1s over p plus 1 p minus 1, which is the same as 4 plus 2p minus 2 over p plus 1 p minus 1. And I can carry that over here and say that that's going to be 2p plus 2 over p plus 1, p minus 1. Once I get to this point, I got to double check and see, can I factor this down? Yes, I can. And I'm going to get 2p plus 1 over p plus 1, p minus 1. And we can see that we have a common factor in the numerator and the denominator of p plus 1, p minus 1. Which means that this is going to leave me with 2 over p minus 1. And this is true so long as, for my restrictions, don't forget to check my lowest common denominator. P cannot equal either positive or -1. And there's my answer.